about now is how to build your own abstractions. And for the rest of the class, we're going to be kind of dealing with that. And we're going to do it, at least initially, based off of this concept of a point 2D. And you'll remember well, let's talk about this first. We had this Yelp data way back in the beginning. And if you remember, we had all sorts of fields for it. We had, I wonder if I can find that data. Let's see. Is that around Lecture 13? Nope. I don't want to waste too much time with this. Now let me go over here. All right, so we have this Yelp data, and let me pop it up so you guys can see it as well. Right, and what we had was this agglomeration of a whole bunch of stuff. We had a name in the first field. We had longitude and latitude, I believe. Was it latitude and longitude? Longitude and latitude. No, latitude and longitude. Yes. We had an address, and the address was a string with a plus separating different fields of the address or different lines of the address. There was a URL for it. There was a type. And then there was a sequence of 0 or more ratings. And they were all separated by pipes. And when we had this data, what we did was we read it into a big list, right? We parsed it out based on this pipe. And then when we wanted to actually access the data, we had to remember that the 0th element was the name, and the first element was either the latitude or the longitude, and the second element was whatever was left, and then the third element was the address, and then it had a plus in there to separate the different fields, and we had a URL for their website, and then we had a type. I don't even remember what that is now. 0, 1, 2, 3, 4. That's 5, and then in 6 through the end of the list were just a sequence of different values. And as you can see by the fact that I can't even keep it straight while I'm explaining it to you, that's a little bit more complicated than maybe we want to do. And part of what we're going to do with these classes is it's going to allow us to abstract that away so that instead of having to remember that element 0 was the name, we will make the name an attribute of our class. And so just like a list contains data, part of the data for our Yelp exercise will be the name, and it'll be accessible via a nice little business.name field or something. And we can do this for all of it, and it allows us to associate this data really nicely. And more than that, it allows us to associate methods that operate on that data. So for example, if we're storing the address as this plus separated list of fields, and we want to get the address, we can do the parsing right on the fly and get the address with the /ns in or without the /ns. We can find out how many lines there are, for example. All of that is something that we can write methods that allow us to kind of capture. And I know this is a little confusing right now, but the idea is we're going to use a class, and a class contains data, right? A restaurant class may contain data on the restaurant, including the name, the location, the URL, in an easily accessible format, and then provides functions that we're going to call methods that allow us to easily get at that data in an intuitive and understandable way. All right, so there's a lot there. But let's stop worrying about our complicated Yelp class, and let's start worrying about something a little bit simpler. let's think about the concept of a point 2D. And we're going to write a class that allows us to do a bunch of operations with point 2D. And what we're going to do is we're going to start out at the absolute simplest class we can write. And we're going to kind of work our way through talking about what the advantages and disadvantages of our current implementation are until we get to the point that we actually have a class built that does a lot of what we want to see. So, for example, if we start out with our point, right, we could just start out, right? We could have x being the x point and y being the y point. And then we can do something like, well, any calculations we want to do. And then we could have like x1 be another point, maybe 3, and y1 be the y coordinate of another point, and that could be 7. And if we want to calculate, for example, a distance, we can say, I don't know, x minus x1. Don't know why I don't put that first. X minus x1 squared plus y minus y1 squared. And then we'll just kind of fill in some parentheses here. And then we'll take this all to the 1/2, right? This is a standard distance formula. So now we have 2 points, right? And they're distance 7.28 apart. We have no idea what these points, what this x is or what this y is. There's no association together. We could easily just put in, you know, when we pass data, if we want to pass data to a distance function, for example, we would have to pass in all 4 of these data points together, and we would have to make sure they were in the right order, and we would have to, you know, keep track of a lot more stuff. So the first thing we want to do is we just want to create a class that's going to continue, that's going to make this association for us. So whenever we create a point, it's going to know what the x value is and what the y value is. Right, so that's pretty easy. We start out here, and we're not actually even going to give it a body. You guys may have stumbled upon this thing called pass. When you're trying to write something like a class or a method or a function, and you don't really want to fill in the details yet, you can put a pass in and it just says, you know, ignore this for now. So we're going to create just an empty class. It's going to be a point 2D class. And I'm going to call this point 2D, and I'm going to call it class because we're going to get to an example later that we're going to want to use point 2D for. Yeah, it's point 2D class pi. That's okay. And if we run this, right now we've now run this file. It's the same as kind of importing it. So now we have this point 2D in here, and we can do something like create right, we're going to import our math functions. We're going to import our square root. We'll create a point, and the way you create a point is the same way you would create, for example, a list. If we wanted to create a list, we would say, for example, L equals list, open parenthesis, close parenthesis. Well, a list is just a class, a built-in class, but a class nonetheless. So now we've defined this other class, point 2D. So we create a new member, a new point class, a new concrete instantiation of the point by doing this point equals point 2D, right? This just says create a point 2D. And then once we do that, now we can say to this point, we can associate an x value and we can associate a y value. And from now on, those x and y are going to travel together as part of our point P. And we can do calculations with them the same way we do with, you know, pretty much any other module, right? When we're talking about modules, you give a module name and then the value you want to access or the method you want to access, like math. I'm going to do import math, and then we can do math.pi, right? That allows us to access the value pi or math.square root pi. math.square root math.pi. Right? So this is the same kind of notation, right? We take the thing we're generating, the point, and this is the data we want to store. In our case, this is the x coordinate data and the y coordinate data, and we can give it values. And now, come on, what did I do? Oh, I went to history. What? How did I do that? Dang it.
At the bottom.
There we go.
Yeah.
Got it. Thanks. Apparently I was flailing wildly, as my son would say. All right. We can look at p. We can say p.x. Well, that's equal to 10. That's exactly what we said p.x was supposed to be. And we can do p.y. And that's equal to 5. And so now we have a point class, and we can define functions based on it. Point print. No, I don't. Oh, sure. Point printer. You guys will see something like this. No, I guess you don't. All right. I can define a function that says print I don't know what I want to print. Point p.x there. That'll do it. Right, and I can do point printer p, and if I got that right, it'll just print out the values of the point. And we can do that just by passing in p, because p now contains two attributes that contain the values for the x and the y coordinate of the point we want to hold. And we can always do this kind of given a class, we can always put attribute data on it. But what happens if we forget? Right? So let's say we create, I don't know, we'll say q is a point 2D. And now what we're going to do is we're going to, right, we got to make that a little function call. And now q is an item of the class, right? We can do type q. We can do type p. They're classes called point2d, essentially. Trying to find my written example so I can keep on track without having to swap back and forth on you guys and give you seasickness. And we can come in here and we can say something like q.x equals, I guess we have -5 in the example. And now we can do something like, let's do our point printer q, and I know they used the distance example, but I like this better because I can pass this in already, and you can see that the data is traveling with our point object. And now, well, we forgot to give it an attribute y, so anything that's expecting the attribute y is going to break. So maybe just defining these attributes every time, particularly for as we get into really complicated classes with more than just an x and y, maybe this isn't such a great idea. So maybe what we want to do instead is we want to build something that will allow us to automatically generate all the attributes we need. All right, so what we're going to do now, if we're just going to move this part, wherever I put this part, we're just going to move this part, and we're going to move it inside of this point2D function. Right? I bet you didn't even know there was a point2D function, which is good. For those of you who did, that's even better. This is like a win-win, whatever happens. But there is. By default, it doesn't do anything. But we can create it so it does whatever we want. So if we define a function, we're going to call it init __, 2 underscores, init, right? That, after we've defined it, gets translated into what gets called when you execute this p equals point2d statement, right? So it's a init function in the point2d class, and it is what gets called here. We need to give it some parameters. So the first parameter we're going to give it is a parameter self. What you'll find out is that any method, any function we put in a class needs essentially self. This name is arbitrary. By convention, we always use self. I'm going to encourage you to use self because it's a good convention and it's consistent, and everybody reading Python will understand what you mean. But having done that, we can do self, and we can give it some default parameters or initial parameters. We'll give it x0 and y0. I thought we did one more step before we got to this far, but I can't find it in the notes, so we'll just do it this way. Oh no, there we go. We did it. Anyway, this is the minimal format we need. We just need that self. Self refers to the object you're working on. So you can define any attributes. I am one step ahead. Okay. Sorry about that. We'll come back to that in just a second. The easiest way to do this is we can just say x equals 0 and y equals 0. And at this point, every time we create a new point, right, if we say p equals point 2d, p is going to have an x value that's equal to 0, and it's going to have a y value that's equal to 0. And we can now call point printer p on it, and we will always be okay because every time we create a point, we come in and we execute this code. But this is kind of boring. If we want to have a point that's not at 0, 0, we now have to go in here and we have to say p sub x equals 5 and p dot y equals 10, p dot y equals 10, and now we can do our point printer, and we get 5 and 10, and we're back where we started from. So this is generally, it makes sure that all the attributes we want are initialized, but it doesn't actually give us any control over what we initialize them to. So the next step is this initialization function I was talking about. This initialization function, if it's there, gets called when you execute this statement. And what we can do is, instead of hard coding what the values are going to be inside the point2d object, is we can come through here and we can give this some parameters. The minimal parameter is self, and we could come in here and give it self.x equals 0 and self.y equals 0. Right, and if we do that and run this, and we do a point 2D, what we'll find out is that this essentially works exactly the same way as directly hard coding x and y into this class. So, we can get that using the initializer, but we can also extend this. So let's say we want to be able to control the values that we create our point 2D with. We can pass additional parameters to the initialization function. In this case, they'll be our initial values for x and y, and we can say self.x equals x0 and self.y equals y0. And now, if we do our point 2D, what we find out is this will no longer run, because it's expecting more parameters, expecting us to pass in an x0 and a y0. And if we pass in those x0 and y0, I don't know, 3 minus 7? 3 minus 7? Sure. then it's initializing our attributes to the values that we pass in. Okay, so now we've come a long way, right? We started off by having, x and y and x1 and y1 just kind of hanging out. And now we're to a point where we actually have this point2d class, and we can attach data to this point, right? The class has a place for us to attach data in x and y, and we can actually even create it in one line so that x and y are initialized the way we want it. Any questions so far? Let me go over to our handy dandy notebook. All right, no questions. Okay, so this is kind of the start. There's one more thing we may want to do here, right? Our class is hashable. Good question. That's very interesting. Let's see. So I think by default they're not. Yeah, this one seems to be. So, yeah, so they are hashable. They are probably being hashed based on the address in memory. But even if it's not hashable, you can make it hashable by creating a hashable function and a hash, or by creating a hash function for your specific object. So you can always extend your class. A hash function that produces a hash is a method on the different types of data. So you can always create, if you have a brilliant way to hash your object, you can always create the hash function, and that will allow you to make it hashable. It looks like right now it is hashing based on the memory address at which this value p is stored. Doesn't it have to be in every class? No. If you don't have anything you need to initialize, you can omit it. And right in the very beginning, we had this down there as a pass, and the class still worked. There was a default initializer that just throws up some space and defines a memory pointer for your class. So there is, there's essentially no way to get rid of that. But you don't have to actually have an explicit one. If you have an explicit one, though, it will get called, and it allows you to do lots of nice stuff. All right. The last thing we want to do is maybe sometimes we just want to create a point at 0, 0 or at some other value that makes sense. We can give default parameters to this as well. So now we can come in here and we can say q equals point2d. Remember, we tried this with x just a few seconds ago, right? And it wouldn't, or with p just a few seconds ago, and it told us you couldn't do that. Well, if we put in some default values and we actually run this again so that we get the default values in there, what you'll see is that whatever we put in here after the equals becomes the default if the parameter is missing. Sometimes you just have to bite the bullet and retype things. Right? So that gives us a 0, 0 point. The cool thing about this is that, well, we'll talk about this a little bit later, but you can define, if you want to define like point r equals 0.2d7, the defaults get applied in order. So 7 gets put into x naught, and then the default y naught equals 0 gets applied. So so r is now 7, 0. Okay, and you can play with that a lot. Okay, init is only the first function we want to talk about. We can make as many methods as we'd like. So we can come in here and, for example, maybe we want to put a method magnitude that tells us the distance of our point from 0. Looks like a regular function. It's indented because it's within the body of the point2D class, right? To define a class, you have the keyword class, the name of the class. This is what you're deriving from. We always want you to use object, although if you get into object-oriented design a little bit more, you'll find out that can change. For right now, just use object, then a colon, then all of your data and methods in an indentation block. So we can do def magnitude. Every method has to have a self, basically a reference to the item you're calling it on. And then we can just come down in here and we can say, well, we should probably say import math. And then we can do something like return math.square root sqrt of self.x squared plus self.y squared, and we probably want to make that a square instead of a double plus. Right? And so that's a magnitude function that tells us the distance from 0. And we could also do something like, I don't know, a distance function. So this just takes the object we're working on. We could do a distance function that takes the object and another member of the class. So another point. Let's call this self and other. I know we used O in the text, but I like to use other because it is easier for you to remember what it is. And then we can do something like, well, it's going to be largely the same line. What we're going to change is we want self.x minus other.x, right? The distance between two points is going to be the self minus the other squared plus the self y. Let's throw in a line break there. Self y minus other dot y squared. All right, so now we've defined two other methods. Unexpected EOF while parsing. That would be that. Okay, so now we've defined two functions, and we can come in here and we can say P equals point 2D 7.3 Q equals point 2D minus 3, 7, minus 3, why not? Right? And now we can do P dot magnitude. And that gives us, 49 plus 9, 58, the square root of 58. That seems like that'd be about 7.6. Or we could do P dot dist Q, and that should give us 10, 636, I don't know, just under 12. Just 9. Bad math. Oh well. Okay, so we can define methods. We can define methods that take just the object itself, methods that take the object and other objects. And, in fact, we can do things like this can be assigned to variables. So we could do length equals p dist q, or mag equals p dot magnitude. And we can look at length, just like any other value, or mag. And we are getting down on time. I've got 15 minutes. Wonder how much I can get through. All right. So let's explain this. Right? We have this p dot magnitude call, and we have this magnitude self. So this is a shorthand for something that looks more like this. Point 2D dot magnitude p. So when you see something like this, you take this function, you precede it by the name of the class, and then you take this guy and you put it in as the first parameter. So point 2D magnitude p is the same as p dot magnitude. And when you see more than one argument in the parameter list, like for the distance function, well, that's point 2D, right? We had p dot dist q. That's the same as point 2D dot dist p comma q. Okay? So all you're doing is you're taking this, put it in as the first parameter to the distance function, and then preceding it by the name of the class. Now, the really cool thing about this, or one of the cool things about this, is that this is essentially how all Python objects are. An integer is actually just a member of a class. So if we have an integer function, let's say, let's use a list instead. We have L equals list, and we want to do an L dot append 7 or 8, whatever my fingers hit, right? We can look at L. This is the same as list dot append L comma, well, 345 maybe. And it works the same way. So everything you have in Python is a class, and whenever we're doing things like all the dot append functions or the dot pop, all of those functions, they're just calling a method in the list class, and whatever object you're calling it on becomes the first argument to that function, to that method. Okay, as usual, we're lying about the lecture exercise.